Hello everyone, we are Team Zion and we are going to discuss the wondrous word of data warehouse. Before we dig deep to the word of data warehouses, let's first define what a data warehouse means. According to the father of data warehouse himself, Bill Inma, a data warehouse is defined as an integrated, subject-oriented, time-variant, non-volatile collection of data that provides a support for decision-making. From that, let's look to the features that define a data warehouse to broaden what we know about it. First, a data warehouse is integrated, meaning a data warehouse is a centralized, consolidated database that integrates data derived from the entire organization and from multiple sources with diverse formats. Transforms data from multiple or different sources into a consistent format, meaning all the naming convention, all the formats of the table, and the encoding must be consistent in order to create a data warehouse. Second, a data warehouse is subject-oriented, meaning a data warehouse is arranged and optimized to answer subjective questions coming from diverse functional areas within a company. Data are organized and summarized by topic. In short, it focuses on a subject rather than ongoing operations. For example, subject can be specific topics in the business area in an organization, which can be sales, marketing, or it can be any business usually specific to the organization. Third, a data warehouse is non-volatile, meaning once a data enters a data warehouse, they will never be removed because the data in the data warehouse represents the company's history. The data should not change once it entered the warehouse, and previous data should not be erased even when there's a new data added on a data warehouse. The logic behind that was it can be potentially of use and the company or an organization might look on it for references in future needs. Lastly, a data warehouse is time variant, meaning it focuses on current transactions. By being a collection of data stored, all data warehouse transactions represents the flow of the data through time. Once the data are periodically uploaded to the data warehouse, all time-dependent aggregations are computed. As we discussed earlier, we keep the data in the data warehouse, so it focuses on how data change over time and helps the business in studying the trends and the changes that took place in the business.
Business intelligence infrastructures, or simply called BI, refers to the procedural and technical infrastructure that collects, stores, and analyzes the data produced by a company's activities. BI is a broad term that encompasses data mining, process analysis, performance benchmarking, and descriptive analytics. BI parses all the data generated by a business and presents easy to digest reports, performance measures, and trends that inform management decisions, all of which will never be possible without a data warehouse. A data warehouse is a major component of the business intelligence infrastructure. Having a successful implementation of data warehouse can bring major benefits to the organization, and some of them were the following. First, potential high returns on investments. Creating more standardized and better quality data is the key strength of a data warehouse, and this key strength translates clearly to significant revenue gains. The data warehouse formula works like this. Better business intelligence helps with better decisions, and in turn, better decision create a higher return on investment across any sector of your business. Most important, these revenue gains build on themselves over time as better decisions strengthen the business. In short, a high-quality, fully scalable data warehouse can be seen as less of a cost and more of an investment, one that adds exponential value like few other investments that businesses make. Second, competitive advantage. This is absolutely the bottom line benefit of a data warehouse. It allows a business to more effectively strategize and execute against other vendors in its sector. With the quality, speed, and historical context provided by a data warehouse, the greater insight in data mining can drive decisions that create more sales, more targeted products, and faster response times. In short, a data warehouse improves business decision making, which in turn gives any business a key competitive advantage. Third, increase productivity of corporate decision makers. Business intelligence and data analytics are the opposite of instinct and intuition. BI and analytics require high quality, standardized data, on time, and available for rapid data mining. A data warehouse enables this power and speed, allowing competitive advantage in key business sectors, ranging from CRM to HR to sales success to quarterly reporting. Therefore, granting accuracy and productivity for key people in charge of making critical decisions for a certain company or organization.
Now, let us move on to the different components of a data warehouse. There are three main components of a data warehouse: the load manager or front-end component, the query manager or back-end component, and the warehouse manager. The load manager or the front-end component performs all the operations associated with the extraction and loading of data in the warehouse. It extracts the information from the data warehouse and loads the data into the warehouse. The load manager is constructed with a combination of off-shell tools, shell script, and C programs. Size and complexity of the load manager varies between a specific solution from one data warehouse to another. Additionally, there are three main functions of load manager. Extract data from source. The data is extracted from the operational database or the external information providers. Gateways are the application programs that are used to extract data. It is supported by underlying DBMS and allows the client program to generate SQL to be executed at the server. Open Database Connection and Java Database Connection are examples of gateways used to perform this function. Fast load. Transformations affect the speed of data processing. Fast load means that in order to minimize the total load window, the data needs to be loaded into the warehouse in the fastest possible time. Simple transformations. While loading, it may be required to perform simple transformations. Simple transformations are simple mapping and conversion of data from one format to another. For example, XML data can be transformed from XML data valid to one XML schema to another XML document valid to a different XML schema. Other examples include the data transformation from non-XML data to XML data. After completing simple transformations, we can do complex checks, which are usually done by stripping out all the columns that are not required within the warehouse and converting all the values to required data types. Another component is the query manager or the back-end component, which performs all the operations associated with the management of user queries. The query manager is responsible for directing the queries to suitable tables. By directing the queries to appropriate tables, it speeds up the query request and response process. In addition, the query manager is responsible for scheduling the execution of the queries posted by the user. Moreover, a query manager includes the following components: query redirection via CTool or RDBMS stored procedures, query management tool, query scheduling via CTool or RDBMS, and query scheduling via third-party software. Last component is the warehouse manager, which is responsible for the warehouse management process. It consists of a third-party system software, C programs, and shell scripts. The size and complexity of a warehouse manager varies between specific solutions. A warehouse manager includes the following: the controlling process, the stored procedures or C with SQL, backup or recovery tool, and SQL scripts. Moreover, a warehouse manager performs the following functions: analyzes the data to perform consistency and referential integrity checks, create indexes, business views, partition views against the base data, generates new aggregations and updates the existing aggregations, generates normalizations, transforms and merges the source of data of the temporary store into the published data warehouse, backups the data into the warehouse, and archives the data that has reached the end of its captured life.
We live in a data-driven world where an enormous amount of data is collected and stored on a daily basis. The more data is generated, the more important it becomes to have the ability to access and analyze it in order to use it effectively. For many, the problem resides in choosing the wrong type of data storage and running ineffective analytics as a result. Building an enterprise-grade data warehouse is a possible solution for effective analytics. So, what is OLAP and data warehouse, and how can it be used effectively? Again, a data warehouse is a database that stores current and historical data so that it can be analyzed for market research, analytical reports, and decision making. The key difference from traditional operational databases is that data warehouses are typically designed to give a historical view rather than to provide up-to-the-minute data, which is why data warehouses are perfectly suited for long-term comprehensive analytics. For instance, companies can use the information stored in data warehouses to monitor or modify their marketing campaigns or improve customer relationships. Earlier, we discussed three components of a data warehouse, which is the load manager or the front-end component, the query manager or the back-end component, and the warehouse manager or the query manager. Just like a house, each data warehouse has its own design of purpose. If we will put the data warehouse in an architectural view, we can see the following tools that make a data warehouse distinguishable. First, we will see the front-end tools, which are the top tier of the data warehouse architecture. They are comprised of the query, reporting, analytics, and data mining tools. Second, there were data sources such as CRM, HRM, SCM, and ERP, which include operational databases that record the company's daily transactions. Third, there was a data warehouse application server, which is the bottom tier of the architecture represented by the relational database system. To build a data warehouse, organizations first need to copy the raw data from each of their data sources, cleanse and optimize it. This process is called ETL, or extract, transform, load. One thing we can also notice from here is that OLAP server is the middle tier and one of the most important components. An online analytical processing server on an OLAP is a set of tools used by the end user to access and analyze data stored in a data warehouse. It is a technology behind many business intelligence applications. OLAP is a powerful technology for data discovery, including capabilities for limitless report viewing, complex analytical calculations, and predictive what-if scenario, for example, about budget or forecast planning. OLAP performs multidimensional analysis of business data and provides the capability for complex calculations, trend analysis, and sophisticated data modeling. And OLAP is illustrated as a cube to visualize its multidimensional analysis capabilities. Since OLAP contains multidimensional data, usually obtained from different and unrelated sources, it requires a special method of storing that data. Using a spreadsheet with rows and columns is good for two-dimensional data, but not for multidimensional ones. Instead, OLAP cubes should be used for that purpose. They are structured in a way that allows for storing various data types from heterogeneous sources and analyzing it in a logical and orderly manner. This capability allows OLAP to involve historical processing of information. OLAP's biggest value lies in its multidimensional approach to organizing and analyzing data. OLAP breaks down data into dimensions. For example, total sales might be broken down into such dimensions such as geography and time. The geography dimension might contain the levels of country, state, and county, while the time dimension might be broken down by year, month, and day. Thus, OLAP in a data warehouse enables companies to organize information in multiple dimensions, which makes it easy for businesses to understand and use data. Beyond just being multidimensional, an OLAP system has additional three features, which includes advanced database support, easy-to-use user interface, and support to client-server architecture. OLAP plays a vital role in meeting organizations' analytical demands by assisting decision makers in fields such as banking and finance, healthcare, insurance, retail, and manufacturing. It allows them to measure facts across the company's most interested dimensions such as geography, demography, and product. The following are some use cases of OLAP's applications to a data warehouse. In healthcare, for example, a data warehouse can be used for predicting health risks and outcomes, generating reports, and sharing data with insurance companies. In the insurance sector, data warehouses can be used to analyze customer trends and data patterns. In retail, it can be utilized to track items and customer buying patterns, as well as determining dynamic pricing. Another example is that a CFO might want to report on their company's financial data by location, month, or product. These elements will make up the dimensions of the OLAP cube, providing ways to transform that data into the requested information. It will also enable the CFO to create a customized financial report quickly and easily. OLAP-based data warehouse can be applied in marketing as well. First, it can be used for trend analysis, as it enables managers to predict future outcomes from historical results. Second, digital marketing relies heavily on data warehouses to encompass versatile data from web analytics, PPC campaigns, display ads, social channels, CRM, and email service providers. Third, many organizations are focusing on integrating data warehouses for market segmentation to get data analysis of customer behavior. That's it. We hope you saw a glimpse to the wondrous world of data warehouses. We are glad we helped you on broadening your knowledge towards this topic. Again, we are Team Zion and we believe that the technology is an innovation to a better future.